It looks like it's 2 p.m. So we are going to start the STEMTank Colloquy. I should mention, what is a colloquy? It's not a word that I made up. It's a word that I did have to look up, though. It is kind of an informal discussion, but more formal than a chat and less formal than a symposium. So I thought this would be a good word to describe what we're going to do today. We're going to share with you our STEMTank program, which was a summer camp that we ran over the summer of 2020 in collaboration with the TRIO program at Santa Fe College. And this was a camp for high school students from, basically socioeconomically disadvantaged areas in North Central Florida. As we'll see over the course of the next 90 minutes, there are a lot of different stories that we want to tell about what happened during STEMTank that ultimately made the program a success. So I'll just sort of give you a preview of all of those different stories, and you'll see elements of them kind of tied together as we go through all of the various guests and panelists that we have with us today in this session. So the first kind of overall theme that I want to mention is the idea that this was both an interdisciplinary and interinstitutional collaboration. So it was an interdisciplinary collaboration in that I'm a mechanical engineer, and I was working with professionals from the UF School of Teaching and Learning, and it was interinstitutional in that it was a collaboration between University of Florida and Santa Fe College. And I think it's really important to point out that Santa Fe College was the lead institution on the STEMTank program, and the University of Florida, played a supporting role. The reason that that's important is because the students that we were serving, the students that we were interacting with, the high schoolers that came and participated in the program, for them, the pathway into a 4-year degree program might not necessarily be a straight path from their high schools right into UF. Santa Fe offers 2-year associates programs and an amazing transfer opportunity from that institution into the University of Florida. So for a lot of these students, Santa Fe was going to be, the place where they started their STEM career pathways and then transitioned to the University of Florida. So wanted to just, make sure that I emphasize that it was a collaboration of two institutions, and important that Santa Fe was recognized as the lead institution in that, especially from the perspective of the students. The other element that you guys will see kind of throughout the presentations today is our interest in creating a STEM pipeline, and a STEM pipeline of high school students who are sometimes underrepresented, particularly in mechanical engineering. So we had a large percentage of our participants were female students. We had underrepresented minorities, and overall our students to be involved in the program had to hail from school districts that were identified as socioeconomically disadvantaged. And as you'll see as we go through the speakers, the program really excited these students about engineering design and motivated them in terms of their self-efficacy, and in a lot of cases opened their eyes to the possibilities of a STEM career. So you'll see that as well. The third element that you'll see is this idea of, okay, we now live in a COVID world, and originally STEMTank was meant to be an in-person program. We were going to bring the students in and spend 2 weeks with them in person at the Merge Lab at UF, teaching them design. And because of the COVID pandemic, we had to switch very rapidly to an all online delivery model. And so we ended up extending the camp from 2 weeks to 3 weeks, and delivering everything online and using 3D printing as the way that the students designed their products, which were meant to help or solve a community. and we were able to rapidly prototype them using 3D printing, and then actually deliver the 3D printed artifacts, the working prototypes, to the students for them to test and evaluate. But that transition from all in person to all online was something that we had to deal with very rapidly, and kind of work our way through technology, learning the technology along the way. So you'll see elements of that, and then the final element, and this again is related to the COVID pandemic, is our staff, our STEMTank staff. So we were able to make that rapid transition from in person to online, because we had a number of University of Florida MAE, both seniors and alumni, who joined our staff, and helped us mentor and facilitate the prototyping along the way, to make sure that the program was successful. And what you'll hear a little bit is this element of, over the summer, our seniors and our graduates had a rough go of it. The economy appeared to be shrinking. People were in lockdown mode, and we had a lot of students that had opportunities lined up that ended up not happening, because of the perception of, kind of the economy downsizing. And so for us, this was an opportunity to pick up a number of staff members that we would not have had because they had internships at companies or at national labs, and we were able to bring them into the STEMTank program instead, and have them work with us, which was amazing. But another key element, is that in this time when the economy is shrinking, and our graduates aren't necessarily able to necessarily get the jobs that they trained for right out of graduation, it was really important in that time period for the students to do something valuable and something useful with their engineering skills and with their time. And so STEMTank provided that opportunity for them, to give back to the community, and actively use their engineering skills. So that's kind of my, from a mechanical engineering perspective, broad overview. Um, I now want to introduce my colleague and collaborator, Dr. Angela Conan, from the University of Florida School of Teaching and Learning. And she will give kind of a perspective from the role of a pedagogical researcher.
Thank you. So, as was just said, I'm Dr. Angela Conan. I'm an assistant professor in the School of Teaching and Learning here at UF, and I'm really honored to be here to talk about the education perspective on STEMTank. I was really fortunate to be able to attend the final showcase event this summer where the STEMTank participants showed off their inventions and talked about their work. And I got excited listening to them talk about a lot of the educational things I was seeing happening or hearing happening in the way they described their experiences. Before I talk about that, I want to say that the School of Teaching and Learning and the College of Education, we have so many ways we think about the educational research frameworks we use. I can't possibly represent them all. We'll hear more about pedagogical research from Adrian Provost too. So I'm just here to talk about one thing that I'm very passionate about in the ideas of teaching and learning, and that is the development of identity. So when I think about learning, particularly identities that are related to practices that we want to instill in students, I think about how do we move people from being novices, from being newcomers, to feeling like they belong, to feeling like they can be an engineer, a mathematician, a scientist, a teacher. It obviously takes a lot of content knowledge. If we want to have a robust STEM pipeline, people need to know a lot of stuff, but you can know a lot of things and still not feel like you have a place in that community. You can know and do, but not be, not become. And so when I was listening to the STEMTank participants talk, I was struck by how many of them seemed to express a sense of destiny to be an engineer. And I thought, so how did they do that? How did STEMTank make that happen? And there's a framework around identity that I find really interesting and I use a lot in my own work. And it says that if we want to invite people to move from newcomer status into a community, we need to think about the resources that we make available to novices. How do we invite them in? How do we give them access to the things that experts know, but also the things that experts, the people experts relate to, the materials experts use? And we think about resources in three ways. One kind of resource is ideational resources, content knowledge, but also dispositions, values, what's good, how do we do this thing, what does the community consider acceptable? So those are ideational resources. We think about those a lot when we design learning experiences. But we also need to take into consideration relational resources, or the people we provide access to. You can go online and watch videos and learn a lot of content, but until you can actually interact with someone who really does the thing you want to be able to do, it's hard to feel like you're a member of that community. And finally, there are material resources, the stuff. Every community of practice has things that people who are good at that community of practice, who belong there, that they know how to use, but that can be really intimidating to newcomers. In the STEM fields, I think that's especially true. We have the devices you use to measure stuff, software programs, 3D printers, all of these material resources we need access to if we really want to develop a sense of identity. So when I was listening to the STEMTank participants talk, I was hearing them talk about the resources they had access to. And it struck me how purposefully STEMTank had been designed to allow for these things to happen. Obviously, they had those ideational resources. These students learned a lot of STEM content. They also learned the values associated with engineering. You look around your community, you solve problems, you prototype, you iterate, you improve. So those were ideational resources. But then, as Dr. Traum was just mentioning, they also had all those relational resources. They talked about the people they interacted with, their UF mentors, their prototype facilitators. And interacting with an expert or an advanced peer and having them take your work seriously, that's absolutely key to developing an identity. And finally, they got all those material resources. They were using things. Y'all mailed them stuff, and they learned how to use measurement tools. They learned how to use software, BlocksCAD. They held their prototypes in their hands. So the next time they're in that situation, that won't be so scary or intimidating. So I listened to them talk at that showcase, and I heard student after student say, I had never thought about being an engineer before I came to this program. Now I think maybe I can, maybe I will. And I think Adrienne Provost is going to talk a little bit more about that when she joins us in a moment. That was incredibly exciting to me. And if you add to that fact, as Dr. Traum just said, this was supposed to be a face-to-face experience, and they were able to do all of that virtually. I mean, I can't tell you how impressed I am with the work that you did. So the identity angle, that's something I'm really excited about. I think can be investigated in STEMTank in future iterations. There are so many other ways we can think about learning and pedagogy, and I know we'll hear about more. If you have questions, put them in the chat. But with no further ado, we really need to invite to join us Adrienne Provost, the director of TRIO programs at Santa Fe, the force behind this program in general, and invite her into the conversation. So hi, Adrienne.
Hi, thank you. It's a pleasure to be with you today.
So can you tell us a little bit about the mission of the TRIO program and how STEMTank really fits into that mission?
Absolutely. So TRIO programs originated in 1965. Actually, one of the acts from the Lyndon Johnson administration brought TRIO programs to fruition. TRIO, everyone thinks it's an acronym, but in fact, it was just because there were 3 initial programs that have since extended to 8 programs. And the impetus for the creation of TRIO programs was really to target poverty. So the idea is that TRIO will assist students who are low income go to a post-secondary and educational program and graduate and succeed. So the programs that we run were primarily targeting our first generation students. They are all rural high school students and all low income students. And we do have a high percentage of minority students in our programs as well. So with Educational Talent Search, we serve 680 students across North Central Florida. We are a consortium between Florida Gateway College, the College of Central Florida, and Santa Fe College. And we also are in 8 different high schools helping students who are first generation and low income identify post-secondary goals and then complete academic requirements that help assist them in achieving the degrees that they will need to move forward into an eventual career that will be helping them achieve something that they've been aspiring to through post-secondary education. So we provide the support and the advising and the counseling to help students recognize their post-secondary goals.
That's great. So talk a little bit about how STEMTank fits in with that and, you know, where it was conceived.
So interestingly enough, this year we had the opportunity to write for an additional grant that was specifically targeting STEM programs for our high school students. So when I was thinking about an idea, we knew the research showed that the amount of low-income students in STEM majors and careers is very low. And we knew that we wanted to not only help students become exposed to STEM ideas and experiences, but that it needed to be experiential enough where the students felt like they had ownership. Going back to a little bit about what you were talking about with identity, we knew that being able to frame an identity where a student felt like they belonged was going to be an essential component in removing kind of those barriers that so many of our low-income students face when they think about a career in STEM. Things like lack of exposure in their high schools to particular curriculum, lack of advanced courses in math and science, things that have already put them behind some of their wealthier and urban peers. So the original idea actually came from the show Shark Tank. I was really inspired by the idea of students when they showcased students who were able to go and come up with a creation and invention and pitch it to the sharks. And so I came about this idea of thinking about a problem that exists in a student's community and asking a student to develop a product that could either solve that problem in their community or teach about that problem in their community. And then the idea would be that we would give them 6 months of experience learning how to code online through one of our online Canvas courses. And at the end of that 6 months, we would invite them into a hands-on experience at the University of Florida with the Merge Lab. Of course, best plans go awry, as happens with COVID. And so we immediately had to pivot and take this idea of a hands-on experiential course into a virtual environment, and we were able to do so. And we did extend it by an extra week, but definitely the idea was in flux with the goal of being sure that we were helping students not only participate with the tools and the pieces that would be part of a STEM career, but that they actually felt ownership and a sense of identity as an engineer. And so we put them in an experience where they would be working collaboratively with people who were engineers, but also people who were in school to become engineers at the University of Florida.
Yeah, that was the thing I really thought was so impressive. So can you talk a little bit about, you had quite a collaboration here. You had the Santa Fe program, the TRIO program, you had the Mechanical and Aerospace Engineering here at UF and the School of Teaching and Learning. Can you talk a little bit about how that collaboration worked, how it came to be?
Absolutely. So what we wanted to do, as I mentioned, is kind of create a system for students where they would feel like they were immersed in an engineering environment. So we put a collaboration in place that I would provide kind of the opportunity to gather the students in one place. And Dr. Traum was really the one to provide the curriculum. And then we also wanted them to have the opportunity to collaborate with experts in their field and students in the STEM field. So we kind of had this three-tiered approach. We had Dr. Traum, who was serving as the professor, who was overseeing the academic curriculum. But then we also had prototype facilitators. These individuals were graduates of Dr. Traum's program, and they served to kind of troubleshoot or be the higher end manage the difficult questions that came out of kind of the product development. But then we also had active students in Dr. Traum's courses who served as peers, so that the students had the opportunity to really connect with someone who was actively engaged in a mechanical and engineering program. And what we wanted students to see was that these students were not that much different than they were. We wanted to demystify the idea that there was a certain identity you had to conform to be part of an engineering program. And by putting the structure in place the way that we did, we removed kind of those barriers for students, and we took away some of that murkiness that they just didn't understand. How do you get from here to there? And letting students know that sometimes that process is definitely not linear. And they're actually able to approach engineering in ways they hadn't thought about before, like developing products through 3D printing.
Yeah, that is so cool. So last question near to my heart. Can you talk a little bit about the pedagogical research that you were able to conduct on this project?
So what was really important to us is that we considered how the students were going to feel about their ability to contribute to the scientific STEM world. So we took a baseline measure of student self-efficacy. From the research, we know that sometimes it's not a lack of academic preparation that prevents students from entering into STEM careers and STEM majors, but moreover, it's a sense that they feel like outsiders or that they don't belong. A lot of times in our current educational situation where we're in a constant high stakes testing, there's this idea that it's either right or it's wrong, that you're either going to be an engineer or you haven't reached that plane yet. So we wanted to really work with student self-efficacy to help students realize that not only were they capable of being involved in a STEM program like this, but that they belonged. So in a basic scale of self-efficacy was administered to them the very first day of our program. And then we followed up with a scale at the end to determine in what ways were we able to move the marker. And what we found is overwhelmingly, this 3-week intervention had incredible success in increasing student self-efficacy, specifically towards STEM-related careers. In 4 vital areas, students were indicating that they had increased their belief in their ability to overcome obstacles, their belief that they belonged within a community, and their belief that they could in fact contribute something of value to the maker or STEM community. Anecdotally, we also found that students were more likely to indicate that they intended to go into a STEM career. When we started, several of our students were kind of on the fence about whether or not they had any interest at all in getting into STEM. And by the end of all of our participants, only one was not directly interested in going into STEM, but that particular student just kind of wanted to take a sidestep into a career also affiliated with a STEM career as well. So overall, what we found is that in this just brief 3-week intervention, we were able to substantially overcome self-efficacy barriers that ordinarily keep so many of our low-income and first-generation students away from STEM careers.
That's really exciting, Adrienne. You should be so proud of this work. I think it's time for you to show us some of those students in your video. So I'm going to step aside and let you introduce them.
So I think that there's no better way to explain the true impact of what the STEMTank program did than to actually let our students tell you in their own words. So at this time, I'd like to share with you a video created by our students that talks about the experience and what they learned along the way.
And I just started my junior year at North Barron High School. When I heard about STEMTank, I realized it would be an opportunity to explore engineering as a different career path, learn more about 3D printing and invention, and connect with like-minded individuals who would help me work on my ability to communicate with others.
Hi, my name is Christine Salmon. I'm in the 10th grade at Bradford High School, and the reason I wanted to do this STEMTank is because I am looking forward to going into a STEMTank career.
Hi, my name is Deani Campbell. I am 17 and a senior at Westport High School, and I joined the STEMTank program because I have an interest in mechanical engineering, and I thought it'd be really cool to design and print my own product just like a real engineer would do.
Hi, my name is Aaliyah Gavaya Richardson, a high school graduate from Westboro High School. Originally going into STEMTank team, I thought to myself, I've never done anything like this before. I got notifications on my educational talent search to sign up. I thought to myself, help your community? That sounds great. So I signed up and got in.
chose what community problem I would be working on, I chose dehydration, as I found a study done in New York that said 75% of people are chronically dehydrated, meaning that they had the symptoms of dehydration and drank under the recommended amount of water per day. Though the study was done in New York, the idea that people do not drink enough water can be carried over to Florida as well, as according to the Florida Department of Health, 4,500 people per year are hospitalized and 13 die from dehydration. The subject was also really important to me, as my family and I often participate in activities where dehydration is a very real and scary thing. We often go hiking and camping. Here is my original design. My intention was to create a water bottle holder you can bring with you anywhere, hands-free. It also has features that give you suggestions on how much water you should drink per day based on the 16.9 fluid ounce water bottle, based on your age and circumstances, such as if you were pregnant, it would be different. You would get these suggestions by moving the switch left and right to change which age is currently being presented. After the prototypers looked at my design, they changed it in one small way. They brought the outer layer down to the base of the holder in order to make my product more manufacturable, as there would be less scaffolding that needed to be cut away afterwards. The idea of having the suggested amount of water on the holder stemmed from a study by Peter Paroli from the Institute of Human and Machine Cognition. The study explored and confirmed the idea that when someone receives reminders to do something, they are more likely to break a habit. So the people that got reminded to drink more water were more likely to drink the water that they bring with them. Some minor changes I would look into for the future would be to add a different type of clip, as some people, such as runners, often do not wear belts and would therefore be alienated from using my product. I would also print or engrave more helpful or cool suggestions onto the outer layer of my product, such as the symptoms of dehydration. I would also like to note two basic problems from my prototype. First, the printing on the infill of the 3D printer was set too low, resulting in the belt loop breaking after some strain. The other problem was the press fit design for the switch. It let the switch come loose after some use. To combat these failures in a future prototype, I would increase the infill percentage on the 3D printer and use glue on the inside of the 3D print design in order to more securely keep the switch in place.
So my problem is I wanted to help the community in my school to be more sanitary because of the COVID-19. So my product functions by reducing the need to touch things that are in public, such as doorknobs and buttons. This reduces the exposure to germs as well as being green and reducing waste of like gloves and stuff. My product description is my product is a multifunctional tool that will be able to open multiple types of doors as well as push buttons. There were changes made to the original design to ease 3D printing as it was flattened. My original design is on the left and the 3D printed design is on the right. My product will almost completely eliminate the need to touch door handles and buttons with your hands. And in the future, I would like to make it adjustable so I can fit all types of doorknobs. And the manufacturing time is 1 hour and 54 minutes. And it can also be put on a keychain as well.
The problem I identified for my STEMTank experience was, how can I stop the glasses from slipping down your face? And the inspiration for this idea came from my own glasses slipping down my face no matter what I did, and I know many people have the same problem. It is also unsanitary to be constantly pushing your glasses back up, because that can be inviting germs and bacteria from your hands onto the vulnerable exposed places on the face. My solution to this idea was a glasses retainer, which is something that hooks behind the ear to keep your glasses in place. Now the objectives for my product were to be sturdy so it doesn't easily break and can withstand the wear and tear of the user, lightweight so it doesn't weigh down on your ear, comfortable so that it hugs the ear without causing any pain or discomfort, and easy to put on and take off so you don't have to take off your glasses to put on my prototype. Here's my box CAD model, which is my original design. And in this design, you would have to press a button at the back and the two top tabs would slide open. You would position that on the arm of your glasses behind your ear, and you would release the button and the two top tabs would slide closed. So there was a few problems that came up with this design though, as it was too small to be 3D printed accurately, and it had to be printed in a few separate pieces, meaning that there was some assembly required. It would also be too bulky and it wouldn't fit behind the ear properly. This is my SolidWorks design, which is a simplified version of my original model, and it fixed most of its problems as it was slimmer, so it was a lot less bulky and exposed. It prints in one single piece, so there's no assembly required, and it is one single large piece, so it's a lot faster and more accurate to print. Looking back at the objectives, we see that the prototype was sturdy, made up of a hard plastic PLA, lightweight, so as it only weighed about 1.77 grams, comfortable as it curved nicely to fit behind the ear, but a softer material could really improve comfort over long periods of time. And it does slide onto the back of the glasses, but you do have to take the glasses off, so that can be improved as well. Some future modifications I would make is a design you see at the right, and that would feature a more clip-on version where you'd simply press it onto the arm of your glasses behind your ear, and it would keep your glasses in place. Also, there could be the option for customizable design, as there could be different versions for different sizes of your glasses and ear sizes, and also a few patterns and colors that could be changed depending on personal preference. I would also try a different material with a few softer plastics like silicone that could increase comfort without sacrificing durability.
So what inspired me to select the primary education intensive reading programs was that I was actually a participant in these programs in middle school. I felt like it was lacking in multi-sensory teaching techniques. I would hope that my product brings interconnectedness between the teacher and the student, bring confidence among the classroom and the reading levels.
My original idea was to have an educational Rubik's Cube. This Rubik's Cube would have vowels going down the middle and then consonants going down the side. So for pre-K to first grade students, this teaching tool would help students learn to develop three-letter words. So they would do cat, dog, across. So my prototype number one, I brought a Rubik's Cube from Amazon and added letters and realized I needed to take it apart to understand the fundamentals of the movement process. So as you guys can see, this is the Rubik's Cube, and then I added letters on it, but I needed to understand how the Rubik's Cube would move, how did it move inside. So I took it apart, and for the interest of time, I decided to scratch it. The abacus. So I feel like we've all known what the abacus is from pre-K. The abacus is a learning product that will be able to create three-letter words while using touch and manipulation of the cubes. So I adapted this fun counting tool to have letters so kids can make words across. The abacus would have rods that come out from the right end over here, and place the three-letter cubes in each row. So this is my prototype I made on Blocks CAD with my mentor. And then this is the one I did with my final product with my mentor. So I want the customer to feel like they can make the words themselves and not the product will do it for them. It's a learning process. So as you guys can see, this is the first row over here. These are the CHAM, that's ham, that's in the first row. This is the second row of the letters we have in each cube over here. And then this is the third row of the letters we have. So this first cube would have these 4 letters. The second row, the first cube would have these 4 letters. And the first row, the first cube would have those 4 letters to make 3-letter words. And then these are the words me and my mentor came up with just so kids could understand. And then the first, second, and third row, the kids would find the word, pick a definition, probably do a picture, and then later adapt it into sentences. The future. So the future of my prototype, I would like to expand to different learning tools like the Rubik's Cube. I would love to go back and accomplish that. And then later adapt to the Da Vinci's Code Cryptex for crafted higher reading levels for like college. and high school students. And then this, the speak and spell, we need to bring this back. I would love to bring this back for just for kids that need stuttering. They can hear the word, say it back, and then it's kind of like Siri. So I would love to bring that back and later adapt to that. So here's the final product, the abacus. As you can see, the letters are on the cubes, and I already took out the screw, and you could just take that out and make your 3-letter words.
While in the STEMTank program, I learned a whole lot more than I used to know about 3D printing and designing products for sale. I got out of my comfort zone. I had to constantly speak in front of 20 plus people, or even 50 plus. I had to get people I didn't know well to understand my thoughts and ideas. I also gained some work experience. I had deadlines. I had people depending on me to meet those deadlines. I had restrictions. I had to think about how to implement feedback or tell people as nicely as I could that I couldn't implement their feedback. I had to be real with myself about what I could accomplish based on my skill level, my time frame, and my available materials. Overall, it was a bunch of experience that I'm glad I got.
So what I got from this program is I've seen that I like doing engineering and things like this, and that helped me, is going to help me pick what career I want in the future and determining what college track I want to do. And that was really beneficial for that.
A few takeaways I had from my STEMTank experience were the amount of researching and time that goes into creating an idea and all the effort that goes into making that idea a reality. Communicating with your peers and mentors can be a really great resource and inspiration for your project. And lastly, being open to change can allow for a better exchange of ideas and ultimately make your product even better because of it.
I just want to say thank you for this experience. Thank you, Dr. Trom. Thank you, Adrian Provost. Thank you, Miss Jody, for pushing me to come into this class. Just thank you, everyone, even the people that donated for this program, because it's awesome. I just feel like in this program, it made me realize like I have the ability to change the world, and like, yeah, because I just graduated and I can change the world.
Okay. Me again. All right, sorry, just transitioning out of the video back into live mode. This is Dr. Trom again. So we're gonna hear from a few of our STEMTank staff members, the prototype facilitators and mentors. But before we jump in to the first interaction, I did want to just remind those in the live streaming audience on YouTube, if you have any questions, particularly at this point now that we're back in a live session, feel free to drop those into the chat. And they will be sent to us, and we will try to address them live. And then certainly at the end, we are going to have a Q&A session where you could type all the questions that you're holding and want answers to, and we'll be happy to get you connected with the right person who will answer them here on the live stream. But don't be shy. Put those questions in as they come up, and we will try to answer them since we're interacting live here. So having made that kind of just reminder, I want to introduce Michael Breen. Michael is a alum and a graduate of the mechanical engineering program here at the University of Florida, and served STEMTank as one of our 3 prototype facilitators. So let me see if we can bring up Michael.
Hi.
There he is. Okay. All right. Sorry, you're off my screen. Now I see you. Okay, great. So I've got a couple of questions that we'd love to hear your thoughts on. So the first one is if you could just give us kind of a broad brushstroke overview, describe your pathway into the STEMTank program.
Yeah, so just to introduce myself to everyone, my name is Michael Breen, and I graduated this past May from UF with my bachelor's in mechanical engineering and minor degrees in business and music performance. So to kind of backtrack a bit, um, I've always been someone who has always known what I've wanted to do at a young age. This has kind of been a blessing and a bit of a curse. So for those who do not know me, I'm very passionate about the entertainment industry, most specifically the themed entertainment. I've grown up along I-4, so I'm fortunate to have grown up with the theme parks. And I had a unique experience at a very young age and was instantly hooked, mesmerized by how do they do that? That kind of crafted my whole life. And I wanted to pursue mechanical engineering and pursue UF. So coming into my senior year, my last semester in early March, I was in the final rounds of interviews at 2 companies, one of which brought me to their facility, gave me a tour, showed me where I'd be sitting. So all the signs were there for an offer. I also had another final round interview scheduled at another company shortly after, all the while earning an internship to fall back on had those full-time opportunities not work out. Long story short, the pandemic happened and all the opportunities vanished. So the reason I bring all of this up is I knew my direction, now past tense. I had a difficult time getting there and everything was beginning to align. And then virtual graduation happened. And the biggest question I heard post-graduation, now what? As someone who is an active planner and organizer, this question was a bit overwhelming. I didn't know what to do. The easy solution would go to graduate school. I'll go back to school. When I'm done, everything will be back to normal. But due to financial reasons and that I could have done the 4 or 5 program had I known this was all going to happen, I kind of took the road that is less traveled. And, I do believe things happen for a reason. And I'm grateful I've been able to be a part of a lot of numerous work experiences since graduation that never would have crossed my path otherwise. And I remember my friend told me about Dr. Chom starting this program called STEMTank. I talked with Dr. Chom and what the role I would be as a prototype facilitator. I remember him saying, so we're basically going to put the high school students in a Mech Design 2 format at an accelerated rate and in a shorter time span. First hearing that, I was a bit skeptical for those who know about the Mech Design 2 course, but I then talked with the role with Adrian and, told me about what the high school students have been doing prior to STEMTank. And I was just kind of blown away by what these students did in engineering just because, to do that in high school already before even going to college. And we worked out how we were going to make an all-day in-person camp into a 3-week virtual program. I signed up, was ready for work. And I have to say, it's probably one of the best experiences I've ever been a part of. I'm truly grateful for the opportunity. And, STEMTank was an unlikely scenario I never thought would happen. I'm so fortunate for Dr. Chom and Adrian for giving me the opportunity. I know that was a bit long, but I just wanted to tell you how I got into STEMTank.
Oh, that's great. We appreciate all those details. That's part of the kind of the story that I wanted to tell, because your pathway was unusual from a perspective of life before COVID, but your experience was shared and sort of common among a lot of our recent graduates and about to graduate seniors. So wanted to make sure that was shared. So we appreciate that. So my next question is, can you describe how STEMTank provided an opportunity for you to use your engineering skill set acquired at UF, but to do something meaningful, but not necessarily in the area where you originally thought that you would use those skills?
Right. So going into what the prototype facilitator role does, we served as the technical support and the designers to ensure the prototypes that the students made in BlocksCAD by the students could be 3D printed and functional for the solution they were trying to solve in their community, as you saw in the previous video. They worked with their mentors for about 2 weeks, and we took the designs they made and put them into SolidWorks and got them ready to be 3D printed. They first established their own set of customer needs and criteria they were upholding their designs to. And we kind of, as prototype facilitators, thought about, design for manufacturability for 3D print. Can this be 3D printed? Is there a flat bottom base for this part to be printed on? What are the printer specifications and the print extent? How big can we print? and even some of the tolerances on how certain parts can be made without having to have scaffolding, and also design for assembly. So, going into tolerances, how we're going to assemble all the parts together, whether they're going to have a press fit involved or not, and what dimensions those parts needed to be. And also the parts were shipped to the students. So, also kind of thinking about shipping in general too. And, the students themselves have a toolkit, and we wanted to make sure they can assemble it with the least amount of tools possible, because I think they uploaded all their designs to Thingiverse at the end of the program, so other people could be able to access their designs. And also did a little bit of FEA on a few of the designs too. But all in all, a lot from the foundation, from SolidWorks all the way through Mech Design 2 on design considerations, on basically a lot of the course loads that I worked on were implemented in just the short 3 weeks working with the students. And we didn't just use the engineering skills, also use kind of the more professional skills that we learned at UF, presenting to these students every single day, knowing your audience, having that communication skills, all were learned by, presenting results in laboratories and design projects and clubs and career showcase and etc.
All right, great. So my final question is if you could please describe working with underprivileged high school students, and in particular, did anything about those interactions surprise you?
Yeah, so there were a few students who would probably otherwise not be able to participate in an in-person all-day summer camp. And having actually the summer camp online actually was more collaborative and more accessible to some of these students, as they have their own personal challenges trying to overcome themselves. So, and a lot of it was, working with them on their design and presentation. And then once, you see their final pitch at the end, it really kind of was emotional to see what they can overcome in just the 3 weeks. And, again, I didn't come from an engineering high school program, and I understand how overwhelmed these students could be during that first week when we started out. But, being able to, you have to be adaptable, learning to work with others, being able to communicate with them on a personal level and on a technical level. And, sometimes it was a bit difficult for them to understand the why behind things with 3D printing limitations, as so much was taught to them in a very short time span. It was all about knowing how to explain it to them, and everyone learns differently. So you have to be quick on your feet. And the most important thing was communication. You can be the most technically competent person, but you need to be able to be personable and be able to relate to another person and communicate, not just talk at them, but really talk with them and make sure that their goal comes along. And, I wouldn't even sometimes consider them to be underprivileged, because as you saw in their presentations, they're very intelligent, they have a bright future in front of them. So.
All right, awesome. Thank you so much. All right, so we're gonna transition to our second panelist, and this is her name is Sophia Ruckel. Sophia is a University of Florida mechanical engineering senior, and she was a STEMTank mentor. So I'll ask her maybe to provide just a little bit more information about herself by way of introduction, and then we'll ask her a few questions.
Hi, my name is Sophia Ruckel. I'm a senior studying mechanical engineering at UF, and over the summer I had the honor of being a mentor in STEMTank. So I got into engineering. My dad's a mechanical engineer, so I kind of followed in his footsteps. And actually, I wanted to be a doctor when I went to the UF preview, when they had all the presentations, but I went to the engineering one because my friend, dragged me along, was like, come on, let's go. And I really, really enjoyed what they had. I really am math oriented and science oriented. So I thought, okay, this is a really good fit with me. So as a mentor, we did not deal with any of the 3D printing of the parts. So the mentors were needed because, these high school students, they don't really have a, background in, these engineering classes like fluid mechanics or, mech design. So the mentors were needed to see if their ideas were, physically possible, because, it's really easy to draft up ideas, but a big portion is to see if the math checks out. The mentors were also available during class time. We were available during office hours. We held office hours after class for them. And the mentors were also paired up with 2 students. So we helped facilitate the design process for them, like from beginning to end. And when my 2 kids were presenting, I felt like they had grown up, and I was so impressed and proud with their designs. So as a mentor, we really gave them advice. We really helped with their ideas.
Okay, great. Thanks for that. As we mentioned before, almost half of the STEMTank participants were female. And so I'm wondering if you could talk a little bit more about your experience as a mentor, and in particular, if you could describe kind of your role serving as a successful female engineer role model for these high school students who are now considering moving on to STEM college and STEM careers.
Yeah, I was not expecting for there to be so many females in STEMTank, and honestly, I really saw some of myself in some of them, and I really wish I had this type of program when I was in high school. Engineering, it's male-dominated field, and I really wanted all the females in STEMTank to feel welcomed, and that any and all of their ideas were just as valid as their male counterparts. Because sometimes I have insecurities that, just because I'm a female, maybe, I'm not on the same level as these guys, but that's honestly not true. Like, I'm just as good. And I really wanted these girls to feel the same way, that they can also do it. Like, they can also be an engineer. At the end of the program, something that really resonated with me was this one girl. She said, now I feel like I can change the world. Like, that's so heartwarming that this program had that much of an effect on her. Like, that's the type of impact that I want, other girls to feel in engineering. And also I was really impressed with these students, because so they applied for the summer program. During the summer, like when you're on summer vacation mode, you don't want to be thinking about Canvas. Like, that's the last thing I want to be doing. And they were able to do their assignments, go to class, like during summer break. Like, it was wow. I was so impressed by them.
Yeah, I was too, for sure. Okay, thank you for that. My last question is if you could talk about new educational or career opportunities that STEMTank participation has opened up for you. So what are you doing now that STEMTank kind of seeded or facilitated?
Yeah, so actually I'll start from in January. I was really unsure if I wanted to take mechanical design too. Like, the whole drop ad period, I was I had my cursor over that drop Mech 2, and I really thought about it, and I'm really happy that I didn't, because it all started with Mech 2. So I took Mech 2 in the spring with Dr. Trom, and I did well in the class. I kind of talked to him a little bit, got to know him a little bit, and my initial plans for the summer was to go on a study abroad internship in Brazil. But, COVID happened, things happen, plans change, it got canceled, and I had no plan B. Like, I had nothing. So my opportunity to join STEMTank presented itself when Dr. Trom, he sent out an announcement that he wanted to help his students who had their summer plans canceled, because, people had their internships canceled, they had all their plans canceled. So, I thought, okay, I'll email him, see what he has to say, because it's better to ask, because the worst answer you can get is no, right? So, I emailed him, and he said, oh yeah, like, I think you're perfect for this summer program called STEMTank, where you're going to be a mentor for underprivileged kids, and you work well with others. You like to talk. You also did really well in my Mech 2 class, so I think you'd be perfect for this. So I joined. I was really happy with it. I love STEMTank. And so when it ended, I think it ended like early July. I kind of had nothing to do. So Dr. Trom emailed me because I became close with him. Talked with him a lot, and he said, "Oh, why don't would you like to be a Vec 2 TA?" And I thought, yes, oh my gosh, finally have something for the fall too. And that's just because I was in Vec 2 in the spring, it had a trickle effect on what I like all my future plans, and I didn't feel so hopeless when COVID happened, and like I was really grateful that I had this opportunity. So yeah, so now I'm a Mech 2 grader, and I'm really happy. I'm really happy I didn't drop Mech 2 in the spring.
Yeah, it worked out really well. And then
really
your plans, your plans moving forward are graduate school.
Yes. So in STEMTank, Dr. Trom brought in one of his former students. She was talking about her I think her window business, and I think she went to MIT also. Yeah. And she said, graduate school is actually affordable. There's a lot of scholarships out there, a lot of opportunities. And that made me think, oh, maybe I could get my master's or get my PhD. And I thought, yeah, I could do it. So now my current plans are to get a master's. I'm kind of unsure about the PhD, but I really want to teach. I really want to teach in universities. So I have to see if I can get if I know that I can do it with a master's. I know some lecturers have their master's in their teaching. So I'm kind of unsure about the PhD route, but we'll see. But yeah, definitely my master's.
Awesome. Excellent. Okay. Thank you. Those are my questions. And as we're transitioning to our final panelist, I just want to remind the audience again that this is a live stream session, and you have the opportunity to ask questions. There will be a Q&A at the end, but if you want to get one in, before we jump into Q&A, we are here live and excited to answer your questions. So our last panelist is Schneily Belize, who is also a University of Florida mechanical engineering senior. And he served as a prototype facilitator, and he's on. Yeah, okay, he's on with us now. So let me just with that brief introduction, kind of transition to Schneily and let him give kind of a further introduction and tell us a little bit about himself.
All right, so my name is Schneily Belize. I'm a fourth year mechanical engineering student. I graduate in December. I've always wanted to be like an engineer, at least like since I was a kid. I didn't know the name at the time, but I know I was always interested in building and creating, and like just seeing like blueprints and like cartoons and things like that. I knew that I wanted to do that in the future. And when I did understand like what the role of engineer was, I wanted to pursue that as my career. So I've just been pursuing that always.
All right, awesome. Okay, so we've talked a bit. Okay, sorry. We've talked a little bit over the past hour or so about the transition from the in-person to online content delivery in STEMTank. And of all of the STEMTank staff, you were kind of the most affected because you were in South Florida, basically Broward County, and we're interacting with all of us remotely from the farthest away. So can you talk a little bit about your remote work experience as a prototype facilitator, and was working online, do you feel easier or more difficult than working in person?
Okay. Well, I felt like it wasn't too much of a difference. Like if I wasn't in Gainesville or back home, I feel like that's like the great thing about being online. Everyone had to be at home, so I wouldn't say it's more easy or difficult because I guess I didn't get to experience what it would be like in person. But I know a couple of things were a lot easier, like say transportation. Like getting to a meeting is pretty easy. Like it's kind of hard to be late if you're at home. But I guess like some things were lost, like just being like in a physical place with the students, getting to build like with them, like side by side. But overall, I think the communication of what like my job was meant to be, like getting their ideas and helping them along the way, putting their ideas like on paper and making it function properly, like fixing errors. I think all that still worked well online. So I think it was a good experience.
All right, thank you. What skills will you be able to take away from STEMTank, and what experiences will you be able to take away from STEMTank as a prototype facilitator that you'll be able to leverage as you graduate and transition out of the UF MAE program and out into industry?
Yeah. So yeah, like I mentioned before, communicating with the students, like taking their ideas, taking their plans, and kind of forming that into a final product. I think that's going to be very useful for me in the field because, say, like a company hires a team of engineers and they may not know how to form something themselves or implement it in like a specific way, but I can take what they desire, like what their need is for a product, and come up with like a prototype or a solution to that. And that is something I learned from STEMTank. Talking with the students who may not be as experienced in these things, I was able to take their ideas and put it on paper. Show them the model, and that they're happy. They're able to see like their idea like put into a physical form. So I think I would use that a lot.
Okay, great. Thank you. So my final question is similar to the one that I asked Sophia. So we did have several of our STEMTank participants were African American students. So can you talk about what it was like to serve as a role model for a successful African American engineering student for the STEMTank participants?
Yeah, I thought it was great. That was one of the things I was thinking about, like in the back of my head as I was, in my position. I did want to be that role model for them, like for them to see someone in the position I'm in that can be pretty inspiring or motivating. Because a lot of times when you don't see people that look like you may not think that this field is for you. But I do hope that me being in this position inspired them and encouraged them that if they want to pursue engineering, it doesn't matter if you're black or white, you can pursue it if you want to. And it also pushed me to just like work harder so that they see that like, I'm doing well, like, and like you said, like, I'm this far in. Like a lot of black students may start engineering, but they don't finish all the way through. But I hope that they see me like I'm pretty much at the finish line at December, and I hope that they know that they can pass that finish line too. So yeah, it was great to be a role model for them, and I hope that they are successful in the end of it. I want to see them one day in my position, inspiring others as well.
Yeah, no, I think they will be, and I think you did a great job as a role model for them. So we really appreciate that. All right, so that's the extent of my questions for the panel. Um, I have just a little bit of a wrap up. Oh, sorry, I think I'm hearing my own reverberation there. A little bit of a wrap up, and then we'll move into the Q&A session. So again, there were kind of four big themes that I wanted us to talk about between the panelists and Adrian Provost. So the first, of course, was the interdisciplinary nature and the interinstitutional nature of the collaboration that formed STEMTank. So Adrian talked a little bit about that. The second one was the creation of the STEM pipeline, particularly for female, underrepresented minorities, and socioeconomically disadvantaged students. So we had several opportunities to hear about that. The third theme that I hope you come away was this idea that we were doing this against the backdrop of COVID-19, in which we had to make a really rapid transition from an in-person program to an online program. So hopefully you got touches of how we made that transition and the fact that it seemed to continue to be successful, even though we weren't able to meet in person with the students. And then finally, particularly Michael Breen and Sophia talked about kind of the downturn in the economy and the effect that it had on employment, and the fact that they had opportunities lined up and those opportunities were no longer available. And so STEMTank was an opportunity for them to pivot in a way that allowed them to continue to use their engineering skills in a way that was beneficial to the community and that could show potential employers in the future that they use this time really well to help out a group of high school students and get them excited about potential engineering and STEM careers. Okay, So with that kind of final overview, I want to hand the floor back over to my colleague and collaborator, Angela Conan, and she will lead the Q&A session. And we actually already have a good number of questions coming through. So I will hand it over to her and let her lead the Q&A.
Okay, thanks. Yeah, there are some great questions on here already, and please keep them coming. So I think the first question might be best answered by Adrian, but maybe also Matt as well. There's a question about following this cohort of students. Will you continue to support them as they continue in their academic endeavors? I had sort of a similar question. Is there any longitudinal plan for research with this cohort? So Adrian, do you want to take that one?
Absolutely. We do intend to continue with STEMTank every year. We know that as we move forward, funding will be an issue. As I mentioned, this particular rendition of STEMTank was funded by a supplementary grant that the Educational Talent Search Program received for the 2019-2020 year. So we're working on ways that we could potentially receive funding or find other grants that would help to create a similar cohort for 2020-2021. And in fact, our design is that we would bring this year's cohorts, graduates of STEMTank, back to serve as a mentor capacity for the incoming next group. And that would continue to evolve so that they could take the projects that they worked on during this particular session and either revise or enhance or create a new project with different types of STEM technologies other than just 3D printing. So we will continue to make STEMTank happen one way or another, and we will definitely continue to track our graduates. One of our graduates is already in college and has been working really closely with Dr. Traum to kind of see where her next steps will be with the decisions she makes with her coursework and classwork. And then we have several 11th graders who we're going to be working, and their academic coaches, Jody Doer and Teresa Cothran, are working really closely to make sure that we're aligning their last year of study in high school to meet the needs of an application into the college that they're choosing to pursue, which is usually the University of Florida.
Of course, right? Especially after they met all these great students. And speaking of the great students, this next question is for Sophia. So hopefully you can come back on. We have a question about at what level in your education you felt that STEM was not for girls, and where were you getting that message? How do you think that came to you?
Well, I know it's different for everyone, but for me, the doubts really came like my first year and my second year of college. It was when I'd go to my classes and all I would see are just guys, and I would count maybe less than 10 girls in all of my classes, like big lecture rooms. And, it felt really daunting to have all these guys around. And and also what's even worse is I'm Hispanic. So I'm like a double minority in these classes. And it really helped me to have a support system, because I've met so many people, I've made so many friends in all of my engineering classes. Like, it really helps to have a support system to, egg you on and to cheer you on and to keep going in engineering, because, we're all suffering together. So, once these females, like, they get over the initial bump of, oh, I can't do it. Like, it's really, you can do it. Like, you just have to get over that little bump.
So is your support system people at your same level, or were you able to connect with older students or faculty?
It's mostly, actually, I've connected with a lot of faculty members. Like, they're so amazing. Like, they helped guide me. Like, for example, Bruce Carroll, like, I talked to him about, my insecurities. Like, oh, I don't think I can do this class. But he's like, no, of course you can. Like, just take it and, power through it. Or, for example, Dr. Brooks, like, he's so amazing. Like, he also talked to me about grad school and all that. And Dr. Traum talked to me about grad school. It really helps to also, like, get to know your professors, because, they're also people too. They're not just your professors. Like, they like to have conversations, like to laugh, like they're people. My friends they're mostly in my level because we can like talk about our classes or take classes together. I have some older friends, but not, I don't know, I kind of really stick to people in my grade or like in similar classes. So yeah.
Great. Well, I'm glad to hear that you found your place, and it's so wonderful that you were able to serve as a mentor for these other, hopefully future engineering majors, right? Thank you. I have a question here for I think maybe the mentors might be able to answer this, or maybe Adrian or Dr. Actually, probably this is more appropriate for Adrian and Dr. Traum. I'm sorry. So this is a scale up question. It says, I'm so impressed by the participants and mentors and what a fabulous experience this sounds like. But how can we scale this up? How can we make more opportunities for more students? So I don't know if there are plans for additional grants, or what are your thoughts on this, either Adrian or Matt? Hopefully one of you can answer this.
So we intend to continue to seek lines of funding that would open up this particular model for more students. The wonderful thing about TRIO is that with the variety of different schools that we serve and with the variety of different programs we offer, there are so many students that we could open up this opportunity to. And, you know, the one thing I really take away from this experience with COVID is that there is so much opportunity that we actually have open to us now because we're no longer logistically limited. We were really limited in our original design concept by thinking that we were going to need to go out to these 8 different geographic locations and bus students every single day into the University of Florida. But with the use of Zoom and Canvas and being able to work with students remotely, it opens up such a broader audience. In fact, we were able to provide our 6-month coding course to all 680 of our students. So to scale up, I think it's just a matter of securing funding and then working to increase like the programming levels so that we can serve students at different points of entry in their academic career, whether or not they're still in high school. And we also have TRIO programs that serve our college community. So I think that the major obstacle we have is of course, always comes down to funding. Dr. Traum, I don't know if you had some additional thoughts.
Well, you touched on it actually before with the idea of if we're gonna scale, you know, what is that going to look like from a curriculum or a pedagogy perspective, and we've talked about the idea, which I love, of bringing this is the STEMTank alums back, right? So it's all the students that have gone through the process, who are still in high school and still, you know, affiliated with ETS and TRIO, and bring them back and have them serve both as mentors, but then also have them go through in maybe a more advanced engineering design process that involves more manufacturing techniques than just 3D printing. 3D printing was you know, I'm glad that it was there, and it helped us out quite a bit, especially in the transition to all online, because we could do all the fabrication you know, kind of remotely, and then just send the final product to the students. But I would really love to get them into the shop and get them hands-on with some of our machine tools in the Merge Lab, the lathes and the mills and the metalworking tools. And once we expand beyond 3D printing as the only fabrication technique into these other areas, then students can think about different materials. So we were material constrained. You know, we basically could use you know, either ABS or one of the other 3D printing PLA, one of the other 3D printing filament materials. And so everything had to be plastic. And Michael Breen mentioned having to run FEA analysis, right? Because a lot of the things that the students wanted to do required designs that really wanted to be made out of metal or some more robust material. And so when we get students, you know, alums, kind of second round students into the shop and get them working with the metal tools, they can expand into a whole different and more robust field of materials, and that will make their products even that much more better. The other thing that we haven't mentioned, which is an ongoing process, is having the students be involved in research presentations. And so at the end of STEMTank, we delivered their artifacts to them, and they were able to kind of use them and showcase and present on how they were meant to be used. But we would actually like to design research studies around the usability of these tools, and have students collect data on how the tools are being used, whether they are truly solving the problems in the communities that the students identified, and have the students collect data and then present that data in an open research presentation forum, something like the Sigma Xi annual research conference, or maybe like an ASCE regional conference or something like that moving forward. So getting our high school aged STEM participants involved in the research enterprise, collecting data, analyzing data, publishing data, presenting data, and disseminating. Speaking of dissemination, there's another element of it that also was touched upon, but we haven't talked about in great detail, which is Thingiverse.com. And so Thingiverse is a platform that allows makers to design objects that can be 3D printed and then post them kind of on it's basically just an online search engine that allows you to search for pre-existing three-dimensional objects. And so we've posted a number of the students' designs up on Thingiverse, and we're now tracking how those are being disseminated throughout the maker community. So anybody can go into Thingiverse and search for, you saw a couple examples. So like glasses clip to hold glasses on from Diani, or the touchless kind of door opener. So they can now search for those designs, and they're live up on Thingiverse. And so other makers can download the students' designs and 3D print them themselves. They can modify them if they want, and they can use them for their own purposes. So not only are we solving problems in the direct communities of the students who are STEMTank participants, but also their work is disseminating outwards and solving problems in other people's communities. Anybody can download these things, and with a 3D printer can print them and then use them in their own communities. And so kind of, again, part of kind of growing this and moving this forward is I would really like to explore that dissemination element of it. Right now, we're just kind of tracking, how often these things are downloaded. But I would love to show examples of how other makers are using the designs that our STEMTank students have developed to solve their own problems in their own communities.
That's really interesting. I'm going to ask you to stay on for a second, because the next one I think you may also be able to answer, as well as perhaps Adrian. So this question is, from your experience, what elements of STEMTank could continue to be online? You both talked about some advantages of online, and what do you think really would have been better in person? And my follow-up, this is my own question, is anything that you've learned about doing what really is hands-on learning virtually. So I would love to hear, if you learned any lessons about how to make that happen. So first one is, what do you think you could continue to offer online, and what would you rather see face to face?
I'm hoping Adrian pops in.
So we actually left our 6-month 3D coding platform active in our Canvas program that we have for all of our educational talent search students. And that will continue to live there for students who weren't able to get through all of the content. And that would allow them to be eligible to join next year's STEMTank program. The one challenge you have there's two major challenges with a remote program versus an in-person experience. And the first one, I think, is kind of related to identity. And that's the idea that there is something very specific about the experience of being in a place to feel like you've become part of a place. And the idea of being able to bring the students on campus to have them experience the sights, the smells, the sounds of the Merge Lab, there's something that you can't reproduce in a virtual world. And the second kind of barrier is that there is a limit to the amount of tools that can be utilized. I mean, there are things in the Merge Lab that we couldn't potentially ever be able to have students access. But I do think this would be a really great time for Dr. Traum to kind of explain the incredible ability our students demonstrated through virtual instruction with the set of tools that we did provide them with, because it was really quite remarkable.
Yeah, so I can talk a little bit about that. So, and I'll try not to geek out too much here because this is really heavy into mechanical engineering now. So talking about measurement and precision. So what we ended up having the students do is we mailed them a toolkit, and the toolkit included calipers, micrometers, feeler gauges, power meter, a voltmeter, current meter combination. So they had like the basic tools of measurement required to do engineering design. And we couldn't teach them in person how to use those tools. And so we had a series of online demos where both live and asynchronously, I walked through how to use some of the measurement tools. And one of the things that really surprised me, and I hadn't intended to do this. It just sort of happened organically, but we gave the students an assignment where we were asking them to use the micrometer to measure a known dimension. So a dimension of a known object that we sent them in their kits. And, it was a machined object. And so typically, for a machined object, you expect, a particular precision. And if I had asked, for example, a technician in the lab to measure, take the same measurement, that person would have returned, here's the measurement, and then here's the precision of the measurement, and done. What ended up happening when the students took the measurements and we were able to aggregate all of their values together and take averages and standard deviations, this group of, I think we had 11 ultimately students who took the measurement, they ended up getting a more accurate and more precise value collectively than I would have expected from just having a technician, a trained technician who works with engineers every day, take the same measurement. And that was sort of the moment, right? Adrian and I, of course, we're in Zoom, but we're sort of looking at each other and we're like, wow, like we could actually teach the students remotely how to use all these tools. And not only can they use them, but they can use them to an extent which we get a result that is at least as good and possibly even better than had we asked somebody who's a professional to take the same measurement in person. And so that was, again, I hadn't planned to turn that into kind of an interesting academic question, but it evolved organically in that way. And so, again, when you're thinking about kind of, how to do this moving forward, one of the elements that we could potentially do, given that we now have some evidence for success, is to have maybe the first week of STEMTank be virtual, and use that week to do all of the training on how to use the tools and how to use the software, how to use Zoom and BlocksCAD and SolidWorks, training on how a 3D printer works. So all of the foundational stuff that can be done remotely, I think we can continue to offer that completely online. And Adrian was talking about cost and funding being a challenge. I would love to bring the students on campus into the Merge Lab and work with them in person for sure. But as we're thinking about keeping this to within a reasonable budget, one way to do that is to have a portion of it done, maybe the first week done online, and save the cost of bringing all the students in. And then once they have that foundational skill set, to bring them in for the second 2 weeks and work in person. So I think that Adrian and I will need to talk about that more. But I think that could be a good hybrid model moving forward, to take advantage of what we learned about what the students can do if give them remote content. They can take measurements as well as a trained technician, even just from watching a video and kind of watching me do it live on Zoom.
Yeah, I remember you saying that at the presentation this summer, and that was really impressive. So it sounds like I had written a note too about potentially almost having an introductory portion that could be open to many more students and be online, and maybe something advanced where you come into the lab and get access to these other tools. There are so many possibilities here that I'm excited to see what you all come up with. We have time for one last question. It's actually for me, so I guess I will pose it to myself and do my best to answer it. And this question is, what do you suggest we faculty do beyond what Sophia mentioned to make female students feel more confident? Some of my best undergraduate students have been female. And I think this is a really interesting question. I would love to connect you with Dr. Rose Pringle, who does a lot in my department around female representation in STEM at the K-12 level, but probably she's learned a lot that would apply here too. I think from what I know and understand, these issues of feeling like you belong, they're or don't belong, are so pervasive. It's a matter of not seeing yourself represented. And so I know some faculty are reluctant to show special treatment to certain groups of students for fear they look like they're singling them out or favoring them. But I think when students have never seen themselves represented or only seeing 10 females in a huge lecture hall, the male students often have received plenty of messages that they belong. So sometimes a little extra encouragement is warranted. It's just a rebalancing. I'm reminded of, Google has corrected this, but a while back, someone typed in English major who taught herself calculus, and Google suggested they were really looking for English major who taught himself calculus. So it's baked into our algorithms, it's baked into our life. And I think it's going to take a lot of outreach and making people feel like, yeah, you belong here, you can do this. So I feel like I could share, connect you and share more ideas, but if I had all the answers, man, we would have more students, female students in STEM, wouldn't we? I think we are out of questions and we're about out of time. So once again, thank you to everyone for being here. Thanks to all of our panelists. Thanks to those of you who have tuned in on YouTube. This will be available after it's ready to be put up, so you can view it again later. And this concludes our colloquium on STEMTank. Thanks to everybody.